Welcome to the Impact Storytelling Podcast. I'm your host, Sabine M, Probst Saavedra, ocean conservation storyteller and organization director. And today we meet Dr. Nicole Todd, a postdoctoral researcher dedicated to understanding how harbor porpoises live, move, and communicate in Ireland's coastal waters. Through her research on acoustic monitoring, Nicole studies how underwater noise, one of the ocean's most pervasive pollutants, affect these sensitive animals. Her work is helping to shape how marine protected areas are managed, how we design offshore development responsibly, and how we can balance renewable energy growth with the well-being of marine life. We'll talk about what it means to listen to the ocean, literally, how sound reveals patterns of porpoise behavior, and how her research is guiding European conservation efforts and policy. Because protecting these small cetaceans isn't just about science, it's about stewardship, learning to share the sea in a way that allows all life to thrive. Welcome, Nicole. Can you take us back to where your interest in marine mammals first began? Was there a defining moment that set you on this path towards studying porpoises and underwater acoustics?
So I guess in some ways I'm kind of a bit of the cliche, like I've always wanted to be a marine biologist. And I know people say that, but I grew up in like a coastal town in Northern Ireland. I lived by the sea. I wanted nothing more than to be on, in, or near the water. But a little bit controversial that my first encounter with dolphins was in SeaWorld, and I don't agree with that now, but that kind of started a fascination. I was like 6 or 7, and I just was obsessed with dolphins. I was reading like animal art books, Dolphin in the Deep. Um, I was about 13 when my mom, they're like, we went and swam with dolphins, and I, at that time, was like, I just said to the trainer, I was like, "How do I get your job?" Because I just wanted to be like so close to dolphins, and I really wanted to work with marine mammals. But fortunately, as I kind of, got older, I went into my studies. I went to university to do my undergraduate degree, Queen's University Belfast, and then I learned that, obviously animals in captivity is not good, and I started to learn more about marine mammals in the wild and ways that I could study them and work with them. I did a project on seals actually during my undergrad, looking at the effect of tide on seal behavior and how they're kind of, if they're pushed together, does that increase their aggression or their interactions with their calves, the pups even. I'm thinking of porpoises. And but then through a supervisor I had during the undergrad project, he had worked in Cork previously, which is where I am now, and he was like, "Oh, there's like a really good data set. If you're going down to Cork, we have some project that might work for you, if you want to work with marine mammals." So he kind of set that up that I was able to do a master's project looking at the effect of construction on marine mammals. So it kind of all kind of started as like, I love dolphins, and then there was some steps along the way that actually made it into the area.
Yeah, that sounds like an awesome start. I was wondering, did the pups were actually more aggressive or the seals were the more aggressive when the tide was pushing them together? What did your research say?
They were a little bit. They were. It did increase aggressive behaviors because, like, seals kind of like their space on the breeding colony, and they like to protect their pup. So when other maybe males or females, like adult seals, were um closer, like were kind of pushed closer to them when the space on the colony was much reduced, and they started to get a lot more aggressive. And then um, then they might not be giving as much energy to their pup. So it was interesting because we were looking, okay, well, if depending on where seals breed, how that can affect their behavior, and if you have increased like storms or big tides, and if that's affecting the breeding colonies, how that might ultimately affect their like population structure and survival. So
I would definitely also be angry if people get pushed onto me. Mm.
I know. They start kind of doing like the flapping of the
Mm.
arm. People's like, "Oh, they're waving at me." I'm like, "No, they really don't like you. Like, please
Yeah.
move away." Yeah.
And you've chosen to specialize on harbor porpoises, one of the most elusive and quiet marine mammals. What is it about this species that captured your attention?
Yeah, so it was the master's project that I did, which looked at like harbor porpoise and dolphins up in the northwest of Ireland, Broadhaven Bay. Looked at their where they were in relation to a construction of an underwater gas pipeline. So through this, I kind of got experience handling like it was 9 year data set of acoustic monitoring data. So it's my first experience of. I didn't get to go put the devices out, but I was handed loads of this data. I was like, right, okay, there's lots of things we can figure out here. So I was really interested that they were affected by like tidal patterns, that their occurrence changed like seasonally, um, and just to see like how the construction really affected their behavior as well. Like it would just their occurrence like so we were wondering if they moved out of the area or just moved away from the construction, but they did tend to come back, which was really interesting that they were disturbed, but they still find that area important for their life cycle. So um, I ended up using some of that data as well as part of my PhD, and looked at, okay, so we knew when they were there, but we wanted to see if they were like foraging and stuff. So, um, like yeah, using acoustics was very useful for that because, um, porpoises and dolphins and other cetaceans can they use sound to communicate, navigate their environment, so that can help us identify where they are and how they're using an
Hmm.
area.
It sounds really difficult to find all of that out from acoustics. How are you doing that?
Well, it depends on the device that you're using. So in the acoustics in you can do there's a lot of different. So it's like an underwater microphone. You can, if you're doing a short survey, you can tow this hydrophone behind a boat and use real time software to analyze. You get the information on the frequency, like the amplitude, all the acoustic parameters, and you can analyze. And if you're familiar with previous research, you can go, oh, and that frequency range will be this species we know. And previous knowledge of the area, you can make kind of educated assumptions of what's there. You can also the data that I used came from devices that you deployed underwater, about 5 meters above the seabed, and they can be deployed for like 3, 4 months at a time. And these ones, they're called click detectors. So they're not like full sound recording hydrophones that record like a sound file. These ones have inbuilt classifiers and processes that they already know that there's a certain number of features that they can already know that's a porpoise detection or that's a dolphin detection. So they detect those clicks, and you can analyze the data afterwards and visually validate it and go, yes, I agree, that is a porpoise, that is a dolphin. And then you can also analyze the acoustic data further to kind of learn more about when they're there and timings. Yeah, you kind of can process a lot more afterwards, but the system does kind of do some of the initial work. So they're quite easy to use for people who maybe if you're in areas that don't have a lot of money or resources, they're very accessible for researchers.
Amazing. And for those unfamiliar with harbor porpoises, what makes them so unique and different to other small cetaceans like dolphins?
Yeah, so a lot of people are more familiar with dolphins. I think they're quite charismatic. We've seen them in like beloved movies, like I don't know if you know Flipper. And they interact with boats or like jumping out of the water, and everyone's like, "Oh my gosh, yay!" A porpoise isn't gonna do that, which maybe makes them a little bit less exciting for some people. But so a harbour porpoise is a porpoise we have in Ireland. Uh, it's one species. There's 7 species of porpoises globally, and porpoises in general are much smaller than dolphins. So the harbour porpoise is about 1.5 to 2 meters in length. They have like a little triangle fin, different to the dolphins. They might have more of a they call it like cyclical shape fin, kind of more curved, in the middle of their back. And dolphins also tend to have like a longer nose, or they call it like a beak, whereas porpoises are like short and stubby, with little round bodies, like the horror porpoise. They actually call it like the sea pig, is like in some regions, in Irish I think it's McNamara, which is sea pig. So here in Ireland they are found like all over our coasts, but because of their short fin and small size, and they also tend to avoid boats and not have that charismatic behavior, they can be quite hard for people to spot. Um, so, and people also might confuse them in Ireland with smaller dolphins. So in Ireland we have main dolphin types would be bottlenose dolphin, which is like flipper, or common dolphins, which are a much smaller dolphin, a couple of meters, with yellow and like light belly almost. So people can kind of think, oh, it's a small that's much smaller than what I'm familiar with as being a dolphin. So they would think it'd be a porpoise, but yeah, porpoises aren't going to be in groups of tens, 20, hundreds of animals. They're kind of much more solitary. They kind of maybe groups of 2 or 3 animals mostly, or on their own. And just yeah, not as they don't stand out as much for people, but I kind of like that. They're kind of like the underdogs.
Yeah, it's nice. And how do they live and communicate in the waters around Ireland?
Yeah, so they use sound as their primary sense, because the waters are like quite murky. It can maybe difficult to see more. I don't know if you've ever been diving in like these waters, like you can't see very far. So they use echolocation, which is a process used by all dolphins, porpoises, where they use the reflective sound, and the sound bounces off objects in their environment. That can be like rocks or the seabed or a fish. Um, and then they receive that sound. It gets returned, and they process it with the fat and fatty complexes in their lower jaw, and they process that information, and it almost gives them like like they're seeing an image of what that sound captured. And sound can travel much farther than it can underwater than it can in air. So they could get information with sound used across miles. And they can determine the size, the shape, the speed of the object. Like they could determine what their preferred prey is. So it's a very interesting process, and like, it's not just dolphins that it could locate. Like a lot more people might be like bats. You know, if you hear like the chirping and clicking of bats. Um, so some shrimp and fish, and even some like cave dwelling birds have it found echolocate. So they think it's can be an adaptation for like low visibility. Um and it Yeah, we kind of can facilitate that to monitor them with the hydrophones, the microphones. So yeah, it works for me.
Very useful. We should have that for the night as well so we can see where we're going without the lights.
Yeah. Well, they have some humans actually have learned to
Mm,
echolocate. Like there's a blind guy, Daniel Kish, I
mhm.
think is his name. He did like a big TED talk, and he learned to echolocate. Like, he's blind and he's like riding a bike and he can produce clicks and he can navigate the environment, which is, it just seems crazy to me. I'm like, oh my
Yeah.
gosh, how can you do that? But he can.
It's
So
amazing that you can learn that, yeah.
there's hope.
Yeah.
Yeah.
I think if one sense is less active than the other senses or can be trained to be
Yeah,
better, I guess.
maybe.
Yeah.
We can all
Yeah.
adapt.
Your PhD focused
Yeah.
on the acoustic monitoring of harbor porpoises. Could you explain how this technology works
hmm
and why sound is such an important tool for studying them?
Yeah, well, I guess it is about capturing that sound that the animals they're emitting for part of their daily
Mm-hmm.
lives, for, as I said, for navigating their environment, for feeding. So we're recording that like as they're doing that. So it's a non-invasive monitoring technique.
Mm-hmm.
You basically put this device in the water, and the dolphins and porpoise can go about their day as they would, and then we can use that to determine like where they are and what they're doing. We can process acoustic data to kind of tease out different behavior.
Mm-hmm.
Um, so you can kind of really refine your kind of management or conservation of that species based on how they're using a certain environment.
And you said you put
Um,
devices underwater and you had sent me some pictures. Maybe we
mhm.
can take a look at what you sent me and what exactly
Mhm.
that is.
That's the click detector.
Mm-hmm.
So it looks like kind of it's like a tube.
Yeah.
That's the hydrophone.
Oh.
Um, and it's a very interesting device because you think it'd be very some hydrophones they look like you would expect like a microphone to look like,
Mm.
but these click detectors, it's a long cylindrical tube that you put an SD card in and like 10 D cell batteries, and then leave it for 4 or 5 months, and it comes back and it's recorded porpoises, which um yeah, it's like magic. But yeah, because they've got all they've got like a processing card with inbuilt. So yeah, it's basically just there's like a white bit at the top is where the hydrophone is cased, and then the rest of it is where you put the batteries
Mm-hmm.
and the lid. So
Do they sometimes get
yeah.
lost as well, or do you always find them?
Uh, no. The first time when I was deploying my gear at the start of my PhD, I started my PhD uh like the end like September 2019. So as I was about to do my first field work on the 17th of March 2020. So that didn't happen because COVID. So I ended up having to try and set up these devices and figure out my like deployment plan. Like I was setting up the devices in like my back garden with like the ropes and the moorings. So the first time I deployed them, I lost one of the devices because maybe I didn't set up the mooring correctly or whatever. But yeah, it was. I mean, they're, as I said, they're cost effective equipment, but they're still pricey for um equipment. But yeah, anything you put into the sea, we have a saying that you may not get it back because like the sea is yeah, it's quite changeable. It's yeah, you just go, "Good luck," and every time you go to collect them, you're like, "I hope it's there." First of all, yeah, I hope it's there, and then second of all, I hope it recorded. So, yeah, that's me and the fishing boat. So, um, we also had an interesting time as well because we thought that we could deploy them and retrieve them from our rib because we have a rib in work, and we were like, "Okay, we'll go diving and we'll dive down and we'll collect the device off the mooring line." And then the visibility was just so bad, and this was cold. It was November in Ireland. That didn't work. So I was like, right, okay, I need to go another way. So I was trying to get contact with a fisherman, a local fisherman in the area, and he had like a pot hauler so that they put the rope on and they can wind it up like they do with like lobster pots. Um, so that was a like a lifesaver because he was able just to grab hold of the surface buoy and completely wind up the mooring, um, to retrieve the devices, which, yeah, it was much easier process. But um, with research, it's a bit of a trial and error to find the right monitoring ways that work for you and your kind of deployment plans, which was a bit of a, yeah, trial and error to start
Yeah.
with.
Yeah, but good that you found the solution.
Yeah, we did, yeah, yeah. And then once it worked, we stuck with it, and I was able to record for they recorded for like 2.5 to 3 years. So I went
Wow.
out every 4 or 5 months. I went out, I changed the batteries, changed the SD card, brought the line up, put a new device back out. So that's a nice, clean, freshly deployed device on the mooring line before it goes back to the sea.
How long are these lines? How deep
So
are you usually putting them?
it depends on the depth of the water. And my devices were the seabed, the depth of the seabed there was about 20 meters. So I had them deployed about 5 meters above the seabed. Because if you deploy them at the seabed, you risk kind of getting a lot of noise of it banging up the seabed, or sometimes you can get like snapping shrimp, which have they like high frequency noise that kind of sounds like clicks, so the device can get confused and think that it's dolphin clicks and porpoise clicks, and then they classify it as, so it's like a false positive. So then when you're doing your data validation, you have to go through and go, that's not a porpoise, um, which can cause a lot of problems for analyzing if you have to do that for like months or years
Yeah,
worth of data. That could be quite problematic. So
sounds like it.
yeah, not ideal.
And here, do you have a double
Yeah.
microphones?
Yeah, so this was if you can see that the one on the
Mm-hmm.
left, the white bit at the bottom slightly longer.
Mm-hmm.
Um so that was a newer model of the device. So these devices are called C pods. And then they created a new device called the F pod, which is the one on the left. And as I did a comparison study, to compare, okay, because C pods have been used for like decades, so long-term monitoring is really important for these animals to get like patterns of how they use in habitat. But we wanted to know, okay, if they're introducing these new devices, how do they compare in like detection rates for harbor porpoises? So we deployed the two together with the headphones like close together so that they effectively they should detect the same thing. So then yeah, we could compare um detection rates of them
Okay.
uh, together. That was also trial and error to get that frame built. So
Yeah, I can
it
imagine.
was,
Here are older ones.
yeah, they're ones that haven't been cleaned yet. So when they can come out from being at sea for like five
Mm.
months, they were probably even partially cleaned because you can see the lines, like they attached to the line
Mm-hmm.
with cable ties. Um, I've had like seaweed, like 2 meter long seaweed growing on them. There's been mussels. Yeah, you can get like a whole little ecosystem going on the devices. So yeah, they were kind of the center of my existence for 3 years. Those devices. So
Wow. And is it nerve-wracking to wait for months to see if then everything worked? Yeah.
yeah, I mean, it got better. Like I was very nervous the first time, and my like it's so comforting being like part of like a research team here at University College Cork. Because there was other PhD students. Like I'd come back after I'd lost one of the devices, and I was like, oh my gosh, I've just lost like this equipment that's worth thousands. Like, what do I do? Like like I'm gonna be in so much trouble. This is terrible. And they're like, happens all the time. Don't worry about it. Like everyone's screwed up, that you're doing completely fine. Don't worry about it. Like, um, and then every time you're just like, yep, did it record? Um, did I set it up? And yeah, your supervisors and fellow students are just like, that's fine. It didn't work. Okay, what can we do to make it work? And you just learn how to. If there's a problem, you fix it and you adapt, and it's all yeah,
Well,
a lot of learning.
yeah, it's good that you have support though.
Yeah, very much so. Yeah, it'd be very difficult to do any sort of thing in research alone. Like,
Mm,
I don't. I think very few people do. I think it
yeah,
really does take like, teams of people supporting each other. Yeah, and not just the researchers, like the fishermen. Like I go out with, like who knows the area, like
mm,
the back of his hand, like getting that local knowledge, and yeah, it really makes a difference
yeah.
doing projects like that.
And how do
Um,
you interpret the
yeah.
acoustic data, those clicks and buzzes, to learn about their distribution and behavior?
Yeah, so like when you get the hydrophones back, we can look at after we've done the validation, determine that it has effectively told us it's a porpoise. We can look at the click parameters. So you look at the frequency, you can look at the click rates. So harbor porpoise, unlike like dolphins, you might have hear produce like whistles, and it sounds quite social. Porpoises don't produce
Mm-hmm.
vocalization, so they only produce those echolocation
Mm-hmm.
clicks. But through changes in like the amplitude, so the loudness or the timings of the clicks. So we call it the interclick
Mm-hmm.
interval, can allow us to determine behavior. Um, so if they're navigating their environment, they're normally like scanning their head, because they have very narrow, so the echolocation beams out in like a very narrow beam. So they have to scan the head to understand more of the environment. But when they are foraging, for example, it's a bit they're trying to target on a certain fish or school of fish. So as they approach their prey, the interclick interval progressively decreases. As they're trying to track the movement of the prey with fine scaled movements. Then when they, get, like, a meter from the prey, they produce a terminal buzz, which is, like, a very, very short interclick interval of about 10 milliseconds. So that, foraging buzz, um, we can identify, by visualizing the clicks, um, like, clicks over time, looking at the visual images of the click sequences. And you can clearly see the like, okay, regular echolocation, that's decreasing, and it all ends with the that buzz, and that's been seen for like not just porpoises, but various toothed whales like beaked whales, sperm whales, and various dolphin species. We can also use the click rates, very high click rates of like greater than like 100 clicks per second, um, to identify communication in porpoises. It's not well understood, but with more sensitive hydrophones like the F pods, um, it's been shown that it can identify communication, like very high click rate, repetitive click sequences, and that previously we haven't really seen for harbor porpoise. We recently investigated this in some of the data I collected as part of my PhD. It was done by a master student that worked with me over the summer. Um, the method was developed in for the Pacific harbor porpoise in Canada. Um, but it's really interesting that when you have like improvements on these passive acoustic monitoring devices, these hydrophones, that you can learn new things or identify new things about these species. So yeah, that's why having data is also so important, because you can always go back to it as well and try and interpret what's happening. So yeah.
Yeah, sounds really
Um,
interesting. And you've described harbor porpoises as particularly sensitive to underwater noise. What kind of human-made sounds pose the biggest risk to them?
so cetaceans, including porpoises, they spend their like in the entirety of their lives underwater. They can't move out, onto
Mm,
land like seals, obviously. So they're very susceptible to disturbance in the marine environment because if that's their home, like where are they going to go? So sound is so important to them. They use sound to hear everything going around them, and it allows them to gather information about their environment across all directions. Because the speed of sound is so much faster underwater than in air, marine mammals and other marine animals are affected by sound disturbance at greater distances than like sound we might be affected on land. Like if we were affected by if they were constructing something on land, it might be like, oh, that's happening like, 500 meters away, but they could hear it over like kilometers and kilometers underwater because the marine environment is just so different. But the main sources of underwater noise, shipping, so commercial shipping, including like cargo ships, tankers, passenger ships, all of that shipping is increasing worldwide, and that is long term exposure, on different types of ships. And size and hull types and propulsion systems create different noise sequences. So there's a lot of new research going on to try and quiet those. Um, then sonar, you can get a lot of sonar with military operations. And it can be common to detect objects in the sea floor. Active sonar systems work very similarly to cetacean echolocation. So it emits like a beam of sound, and then that returning echo tells them information about what is in that path of sound. But at high frequencies, that can overlap quite a lot with marine mammal signals. You also get similar to sonar echo sounders, but instead of a beam of sound, it's more like a fan, like a swath of sound, which is used to detect fish or plankton. A lot of fisheries use it um, for deep sea mapping. And then you have seismic air guns, are very like loud, impulsive sound, which are used for geophysical surveys. They were traditionally used for oil and gas exploration, seeing if there were suitable areas for like digging. Now they're used a lot for site surveys, for wind farms. So you really have to consider it's more the like pre-construction stage sometimes when the site investigation can be quite loud and damaging for marine mammals. But then construction, sounds like there's a lot of things. So the construction themselves, like dredging or trenching or the pile driving, like if you're creating a wind farm, you're repeatedly striking a large hammer into the seabed that supports the wind turbine. This can be hammering for like hours at a time, and there can be up to like 5,000 strikes of a hammer to hammer that into the seabed, which is quite a loud sound, which can travel really far. But again, that noise depends on like the properties of the hammer, how big the pile itself is, and what seabed you're hammering into. Because if you were hammering that hammering that pile into the seabed of rock, it's gonna be like a lot noisier than if you were putting it in to sand, which might absorb some of that sound. So yeah, there's a lot of different impacts to consider, and if that's in combination with one another. Like if you have construction, there might be shipping in the same area and stuff. So cumulative impact is a whole other trove. to consider as well of
Mm.
what that might impact.
And how can noise affect their ability to forage, communicate, or navigate, and even their long-term survival?
Yeah, so because they're using sound all the time, this extra sound in the environment, depending on the frequency that it's emitted at, it can interrupt their signals and make it more difficult for them to communicate with each other, or decrease foraging efficiency. And this can kind of have, if this happens often enough, it could have population level consequences. So if they're not meeting their energetic needs from foraging, like if they keep having failed foraging attempts, if they're not meeting what food they need, they could be in poor body condition, and then that could have implications for like birth rates. Because if they're not in physical like good condition to birth a calf, then maybe that has like follow-on implications for the population itself. Um,
Yeah.
yeah.
And you just talked a little bit about construction, and you've looked
hmm
into data from European wind farms. What can Ireland learn from those examples when planning its own renewable energy projects?
Yeah, so Ireland's looking to expand the offshore wind sector, and there's a lot of planning going on now, and site investigation, and some wind farm places have been um, kind of confirmed. But it is important to research what's been done in other regions, particularly Europe and the North Sea, because they've had a lot of expansion and large scale wind farm developments over the past couple of decades. In the North Sea, the harbour porpoise is the most common cetacean. They don't tend to have a lot of dolphins commonly occurring, or any baleen whales kind of commonly occurring in that area. So there has been a lot of research done on, like sometimes they've tagged porpoises. They can see how they interact with wind farms that have been developed. They can see there's even some wind farms in that region that are being decommissioning. So there's a lot of research over the various life stages of the wind farms. We want to be able to refer to this research and learn what has been done before, like what potential impacts there were, if there were any, maybe they were positive, like maybe there's been some research done, like they call it from the oil and gas as well, with the rigs to reefs. They can say that sometimes there's artificial reef effect where wind farms can bring in shoals of fish that feel protected under the structures, which can bring in marine mammals that maybe are foraging on those fish. Um, but understanding what impacts these wind farms have had, as well as what mitigation has been effective, how the animals responded, and we can try and learn from that. It might not be 100% transferable because the North Sea, it's quite homogeneous. Like the seabed's quite level. It's quite similar across the North Sea. It's not particularly deep. But in Ireland, we have a very varied marine environment. Like some of our wind farms could be placed in waters like up to like 80 meters, or it's a very different scenario when you're dealing with a lot of new currents, tidal flows, fronts. Um, but yeah, it's still good to learn from other regions and not have to start from scratch. Um, on that
Yeah.
front.
And I was wondering, so once the wind farms are built and they are running, are they quiet then, or is there like some vibration if it's like going in circles that goes down?
Yeah, there are still vibrations and operational
Mm-hmm.
noise, and then you would also have the shipping involved with that operational wind farm and maintenance. Um, some research has shown that it's the construction phase that is the most detrimental for animals like porpoises or marine mammals, because it's just very sharp and impulsive. Um, but the operational wind farms, they tend to come back once the wind farms have been built. Like, they can forage in wind farms. Like, a lot of tagged harbor porpoises have been, like, they'll happily forage within a wind farm. Um, because one of the benefits of having that there is, like, you can't get big trawlers going in, and so you might get the shoals of fish kind of coming into the wind farm. So, and the pilots are going to be spaced out enough that it's not going to exclude them completely from an area. So it probably just depends on, yeah, habitat preferability and where their availability of their prey might be.
Mm. And when assessing these new developments, what are the key questions scientists and policymakers should be asking to ensure porpoises aren't exposed to additional stressors?
Yeah, so when they're putting in place these new developments, one of the key things is environmental assessment. Um, they can include EIA, which is environmental impact assessment, and appropriate assessment. And these are required to be undertaken to assess any potential impacts, not just marine mammals, um, but variety of species at the development site. It is particularly important for species protected under the EU Habitats Directive, Annex 2. So for marine mammals, that would be your grey seal, harbour seal, bottlenose dolphin, and harbour porpoise. So they have to assess, like, what protected areas are nearby, um, what if there's any important foraging areas, where is that kind of zone of influence. As part of those assessments as well, they have to put in place a marine mammal mitigation plan. So that can outline measures to reduce impact and exposure of stressors such as underwater noise. Um, these plans typically follow latest guidance. So marine mammal observers need to be on board in an area. They can include specific noise modeling for that area, and an operational procedures plan, including like ramp up procedures, which is one mitigation approach, where um, for pile driving, for example, the sound energy is gradually increased over like a 20 to 40-minute period, so they don't start on full energy. This gives the animals a chance to move out of the area before it's full impact noise. It's trying to reduce that, like, any direct impact or any hearing loss that might happen when you're within really close range of those operations. And depending on the operations that are planned, these mitigation plans can include what noise abatement or might be appropriate. So that might be like bubble curtains or ways to reduce that noise. Um, and they are reviewed as well, so they can have any amendments of what might be appropriate for that site.
Mhm. And Ireland also recently expanded its network of protected areas for harbor purposes from just 3 to 16. What does that mean for conservation on the ground?
Yeah, so yeah, Ireland had three protected areas, which were Roaringwater Bay, Blaskin Islands, and Rockabill the Ducky Island. Um, these were, because there was only three, it means they could do surveys every 5 to 6 years. It kind of worked well on, like, a smaller scale, streamlined basis. Um, but we have large scale conservation goals, like the 30%. We want 30% of our water to be protected by 2030, which is very close. Um, but so there's a real need to increase protected areas and species management. Um, so with um, so harbor ports were added to additional, like, the SACs that they were added to a special area of conservation already existed, but harbor porpoise was added as a feature to those protected areas. But it will mean that there need to be increased monitoring, increased effort to run more surveys potentially, and gain more data. They'll probably need to work maybe more together, more coordinated effort with using existing data. Um, it might help us understand if porpoises are moving or concentrating in other regions, because we have found in the three areas, three protectors that have been monitoring, there's been a decline in all of them, and the abundance estimates and density has declined. Um, and in Rowan Bay SAC, I monitored acoustically as well, and the acoustic monitoring that I undertook was after the last estimate, so it shown a decline, and then the acoustic data also showed a decline throughout the 3 years. So um, there's a big question around Ireland of what is happening to our harbour porpoises, because Ireland undertakes large scale aerial surveys as well. So it's not just within the SACs it's declining; it's kind of nationally. Um, so yeah, the new SACs might show maybe there's concentrations, maybe these animals are moving outside of these coastal SACs. So using a combination of monitoring techniques, including the visual surveys, acoustics, aerial, we might be able to get a better picture of where the porpoises are, and maybe more effective conservation management, potentially.
So, how would you say that acoustic monitoring can help to ensure these protected areas are working as intended and the purposes are actually benefiting?
Yeah, so I said traditionally for the previous protected areas we've had, they were monitored every 5 to 6 years with visual boat surveys. This is a great way to get your distribution and abundance estimates. Sometimes those surveys had used towed passive acoustic monitoring with a hydrophone towed along the back of the boat, but those surveys are typically in the summer months, so they're really only like seasonal snapshot, which obviously it's quite expensive to monitor an area, like, and going out physically and monitoring those regions. But deploying passive acoustic monitoring, um, statically deployed in the seabed, like with my PhD research, it can be quite cost effective because those devices are recording like regardless of weather conditions, which is very useful here for harbour porpoise, because once it gets a little wavy, it's very hard to spot harbour porpoise. You don't need to employ observers to continuously be out watching, because you can leave these devices for months and they collect the data on species occurrence and behavior. They can't the acoustics passive acoustic monitoring it can't do abundance estimates or count individuals from the static devices, but you can get acoustic detection rates, and like you can see how those rates are changing over time, over several seasons, over years, to give a good indication of how the animals are maybe using the area in between the abundance visual abundance surveys. Um, and then it can be an early warning system, almost given if you see that acoustic rate declining when you're bringing the devices up every 4 or 5 months, you can maybe kind of put in adaptive, if you could adaptively manage an area, you could put in extra measures. You could see, okay, has something changed in the area? Has there been an increase in activity? If, for example, something that might be changing the habitat use patterns of the harbour porpoise. So it kind of gives us a little bit more of an eye into what's happening into the region.
Mm.
Um,
And when you think about priorities for protecting area management, what should come first? Better monitoring, better noise guidelines, or better enforcement, or something else?
yeah, I mean it's tricky because they're all important, right? But monitoring, I think monitoring's important, and especially like to try and get baseline information, because we want to understand like how things are now. I know that The marine environment has already changed, and like it's hard to say what is baseline. But if we can identify what the animals are doing and how they use an area, then that can help us better identify what reaction, what behavioral responses they might have to noise. Um, and then we can better understand what noise restrictions or enforcements might be needed, um, if they're deviating from what their normal patterns might be.
Your work also supports the government's efforts to guide developers on underwater noise management. How does science translate into those policy decisions?
Yeah, so we worked on developing the underwater noise guidance for Ireland as part of it was a research project in UCC, the Gomerius project. So we worked quite closely with the government state bodies in Ireland, reviewing best practice across Europe of what had been done before, with their noise thresholds, their noise management approaches, mitigation approaches, to look at the impulsive noise impacts on marine mammals. The previous guidance was from 2014, so it's quite out of date. And there have been several scientific advances within that time, particularly on like marine mammal hearing thresholds have been updated. There's been considerable updates on mitigation approaches. So this work's still in development, but it's basically about trying to showcase there has been research developments and having that reflected in the guidance is very important to work well with regulators
Mm.
on that front.
And what do you think are the biggest challenges in getting developers and conservationists to work together on solutions?
I think it's quite complicated because it sometimes seems that both sides have different priorities. So I understand for the conservationists and marine scientists, we're concerned about protecting the marine environment, but it's highly unlikely that there will be like zero impact. Um, what we want is to minimize impact, reducing the disturbance as much as possible with appropriate mitigation or like spatial temporal planning so the animals have the capacity to move away. But it's trying to work with the developers in first of all showing the importance of environmental protection that well, if you don't have a thriving environment, then they can't harness that from the environment. But I think cost is a huge priority for developers, and it can be quite a highly competitive market. Um, so it's I think what we need now a lot of the times to show the economic value of the ecosystem, which is a weird way of looking at things as well, but it's just showing how if you protect this is going to like sustain you for years to come. So it's yeah, I guess trying to speak everyone else's language.
Yeah, I think it's often the case that you have to figure out the language of the people you're trying to convince of conservation.
How do they want to hear
Yeah.
it? Yeah.
And earlier we had a look at different pictures with your tools, and you've tested different acoustic devices and detection rates. What have you learned about how far these tools can hear, and how do you choose the right ones for a specific site?
Yeah, so I mentioned earlier about how I mostly used click detectors. They were called C pods or F pods. Um, Long-term data was just so important, so we want to see how devices compare and which ones to choose, and because you want to kind of ask the question of, okay, is consistency better from what we've always had, or is it better to get the new device with increased sensitivity? But how will this affect detection rates? So one of the things we did when we were comparing as well was looking at well, first of all, did they detect similar trends? Because sometimes it's not how many specific porpoise clicks that they detected. Maybe that's not important. Maybe it's important to say, okay, what could we tell was like what season was more important for them, if there was you were still picking out when they were feeding, where they were, which sometimes if you're doing like site investigation, that's maybe the important thing to look at. Um, but if you're wanting to look at specific behavior, the FPODs, the newer, more slightly sensitive device detected like a lot more echolocation clicks. And I think about was like almost like 10 times, almost 10 times as many clicks as the CPOD. So that gave a greater sensitivity for determining behaviors such as foraging or communication. So if you're doing a fine scale study on behavior, you might want to use some more nuanced devices. We also wondered, okay, the FPOT detected more, but is it detecting more because it can detect further? So we designed a playback experiment where we got recordings of harbor porpoises from captive harbor porpoises, and we had the co-deployed, the FPOD and the CPOD side by side, but we also added a full spectrum hydrophone to the mooring, so we could compare like the three of them together. And the the detection range of the full spectrum hydrophone was the greatest, which you might expect because it's recording everything. It's a very highly sensitive devices, but it detected harbor porpoise between 400 and 500 meters. But the F-Pod also detected within that range, showing that it can be a comparable, low cost alternative to full spectrum hydrophones if people don't have maybe the processing skills. Um, the C-Pod did detect um, only between 300 and 400 meters. So that kind of answered the question a little bit of, well, it's not detecting as far as the F-Pod. So that's probably one of the reasons why it's not getting as many porpoise clicks. We also found that foraging buzzes weren't detected as far as clicks. So it shows that when you're monitoring for foraging for behavior, your search area is much more restricted. So that can be important for project planning. Maybe if you're wanting to do fine scale behavioral studies, you might need to put out extra devices to have the same to cover the same area. Um, so and yeah, it's the interesting one that kind of stood out for me as well was just I keep coming back to like long term data is important. So we tried to look at a um correlation factor between how comparable if you have a correction factor between the FPOD data to the CPOD data so that you can use your old data and then you've just kind of converted it to okay, so what does that mean with the new data that's been collected? Like how can we make the acoustic rates comparable? But I think there's a quite a long way to go with that, but there's a lot more people now doing CPOD and FPOD comparisons, like at their sites to know how the two differ in that marine environment. Um, so that would be very useful for individual project planning.
Mm. And do ocean currents, depth, or temperature affect how sounds travel and therefore how accurately you can monitor porpoises?
Yeah, so that's like the speed of sound in water can depend on like temperature, salinity, and depth. Like as depth increases, so does the speed of sound. And that'll affect how sound is propagated in the marine environment. So that's one of the reasons why a lot of different studies are doing their own like comparison for this CPOD and FPOD comparison. It'd be very environmental specific. So how porpoises are detected will change like depending on the environment. Like if you have an environment of high tidal flow, that sound is being carried away much
Mm.
quicker, so your detection range might be reduced from 400 to maybe 100 or 200 because that sound's just not propagating as far. Um, Harbor porpoise also have very high frequency echolocation, so high frequencies don't propagate as far as lower frequencies. So you'd pick up dolphins much further than porpoises, and you'd pick up like you might pick up dolphins at like a kilometer away, but like you could pick up a blue whale at like 1,000 miles away. So it really depends on what you're monitoring as well, and yeah.
Yeah, definitely a lot more knowledge has to go in there than just learning how to deploy them and how to read them. It's fascinating.
Yeah, there's a whole lot of things to consider. Yeah.
Yeah. And looking ahead, in our previous conversation, you mentioned a new project starting in November on marine mammal disturbance in foraging areas. What questions are you hoping to answer through that work?
Yeah, so I'm starting a project with some colleagues. It's called Marine Mammal Appropriate Assessment Toolkit. So Ireland is greatly expanding their offshore wind developments. We have a lot of gaps on where are important foraging areas for marine mammals and how they respond to disturbance within our waters. So the upcoming project is to try and gather this information to support appropriate assessment plans and to support the government agencies and regulators that they can have this information so that they can um, know if like those appropriate assessment plans and removal mitigation plans are maybe up to scratch. So the project will do a review of previous research to understand known impacts of disturbance um, of in Irish waters or referring to other regions where that information is lacking. Um, and also we want to update where marine mammals are, their distribution and foraging ranges, but that's a tricky one as well because marine mammals can forage throughout their range. So one part will use seal data to look at sea distribution for grey seals and harbour seals within Irish waters, based on previously tagged seals. We will also look at marine mammal density maps and associate them with key oceanographic features. So you can in the environment key oceanographic features such as fronts or currents, they can be dynamic foraging areas related to the distribution of marine mammals prey. So overlapping these key prey areas with marine mammal density maps can help us prioritize which areas could be used for foraging and identify zones of potential overlap with the disturbance and marine developments, particularly within the Irish and Celtic Sea.
Hmm. And if a species like the harbor porpoise is already highly sensitive to noise, how do we balance necessary human activities like renewable energy with their need for quiet, safe habitats?
Yeah, so it's a tricky one. I guess people just need to keep talking to each other and like intersector like communication and collaboration. Like researchers can't just talk to researchers, industry can't just talk to industry. Like I think we need to try like work together. If we just keep reiterating the issues and get appropriate support from government agencies and appropriate planning and legislation to try and learn from more developed regions like Europe and the North Sea, and to try and not make the same mistakes. Like if they've made mistakes, we'll try not to make the mistakes so that we can have a safer environment, less reducing the impact where we can. And
Yeah, that's great. And finally, on a personal note, after years of listening to porpoises through hydrophones and analyzing endless data, what keeps you going? And what would you like to tell the people out there about porpoises and their conservation?
yeah, so like living here in Cork in Ireland, like I see so many people who like don't know or don't understand like the variety of life we have here, and like even my family are like, "Oh, why aren't you like in the tropics?" Or like, "Why am I not in like I don't know Thailand or something?" I don't know. But it's just I really want to show people how like a beautiful interlocked ecosystem we have that I really want to protect. Like marine mammals are the top mid to top of the food chain. They're important ecosystem indicators. Um, but ultimately, I'm just like drawn to the sea, and I really want to see it thrive. Like, I'm not going to be like the next Sylvia Earle or something, like, but if I can contribute to preserving these animals and keeping their environment stable and really understanding how they use it, yeah, that's what keeps me going. Like, just getting on a boat, just seeing blubber marine mammals.
That's lovely.
Yeah.
Well, thank you so much, Nicole, for taking the time to talk with me. It was super interesting to hear all about your research. And I hope to have you on the podcast soon again in the future and talk about your newest findings. Thank you so much.